Hey everyone, and welcome back to The Explainer. Today we're stepping into a future that feels, well, completely different from the ones we usually see in popular media. We're continuing our journey through general emergence mechanics, or GEM, but instead of abstract physics, we're pointing this lens directly at our own technological horizon. We're going to explore a deeply hopeful, grounded, and humane vision of what artificial intelligence and robotics could actually become.
You know, it's incredibly common to fear the rise of AI. For decades, our stories have framed intelligent machines as our ultimate competition. They're usually portrayed as engines of anxiety, surveillance, and this inevitable loss of control. But what if we're looking at this all wrong? What if the real purpose of intelligent machines is not to replace us, but to carry the weight that keeps crushing us? Today, we're exploring a radically different possibility. We're looking at technology not as a competitor, but as a stabilizing partner designed to support human flourishing.
Okay, let's dive right into this. Part 1. Partners in Persistence.
To really understand this shift, think of human civilization itself as a massive, incredibly fragile, persistent system. Honestly, it takes an exhausting amount of human energy just to keep it all from breaking down. Let's map our physical GEM axes directly to their civilizational equivalents. First up is depth, which is our energy barrier against breakdown. By delegating dangerous or repetitive tasks to AI, we drastically reduce our society's fragility. Second is stiffness. AI can provide rapid, real-time responses to infrastructure problems before they cascade into disasters. And third, viscosity. Because disruptions will happen, intelligent systems can help us bounce back and recover our coherence so much faster.
Moving on to Part 2, Reframing the Machine Future. Now, I want to be perfectly clear right out of the gate. We are not talking about some dystopian scenario where robots take over the world. We are standing at a very real crossroads, and this brilliantly illustrates the two paths in front of us. On one side, we have the path of anxiety, where we use machines to intensify stress and maximize extraction. But on the other side, we see this GEM-inspired vision where machines are built specifically to reduce friction. In this kind of future, AI acts as a buffer against chaos. It absorbs the shock of complex systems so that human freedom and creativity can actually thrive, completely free from the constant background hum of systemic exhaustion.
Which brings us to Part 3. Building a Coherent World.
So what does this actually look like in practice? Well, if we build systems to optimize for coherence, rather than just raw extraction, the applications are frankly incredible. Consider this for a second. Today, humanity spends a staggering amount of its global energy budget, and honestly our collective patience, just fixing things that break. But imagine quiet little maintenance robots working invisibly to care for our aging bridges and electrical grids, stopping failures long before they happen. We can envision AI systems drastically reducing waste in global logistics. Think about care robots handling the physical heavy lifting, so human caregivers can focus entirely on what they do best, empathy and compassion. Add in adaptive city systems that respond to pressure before traffic jams or power outages even occur. AI scientific assistants accelerating our biggest discoveries, and smart household systems that finally remove the invisible, repetitive burdens of daily life.
And here is why this matters so much. Every single one of those examples ties directly back to our core mechanics of persistence. Fewer breakdowns means we've successfully increased our shell depth. Faster recovery means we've optimized our viscosity. More resilience translates to higher stiffness against systemic shocks. And the ultimate result of all of this? Drastically less wasted human energy. These technologies act as the stabilizing forces of our daily lives.
Now you might be sitting there thinking, okay, this sounds amazing, but it's totally a utopian theory, right? Actually, no. Engineered selective persistence is already working today in computational systems. The source material outlines a real-world proof of concept known as the Frankie architecture. Frankie uses what's called a coarse coherence controller, along with internal mechanisms like phase-weighted attention, to implement a selective persistence regime. In plain English, it actively measures how stable or unstable a computational state is, and it adjusts its energy expenditure accordingly.
Now, what's really interesting is when we look at the hard data, the results are astonishing. By applying this GEM-style coherence-aware control, the Frankie architecture massively reduces friction. It preferentially invokes costly operations only when the conversational state becomes unstable or analytically demanding. The result is a 37% reduction in token usage, a massive 47% drop in latency, and a 27% reduction in overall computational work. It achieves these incredible efficiency gains without collapsing the quality of the output. It is literally a working model of how intelligence can stabilize a system from the inside out.
Let's look at Part 4, the human consequences. So, what do these mechanical and computational improvements actually mean for you and me?
The consequences are profound. When we are no longer forced to act as the shock absorbers for fragile infrastructure, we experience far less physical and mental exhaustion. It literally liberates human time and energy. Suddenly there's more time for family, for deep craft, for learning, for art, and for exploration. We get safer physical systems and a massive reduction in that ambient background stress we all feel when society's systems are straining. This is a future where intelligence serves life rather than consuming it.
Moving to Part 5. Possibilities, not promises.
But we really have to stay grounded here, because with incredibly powerful capabilities comes serious ethical realities. We have to ask the hard questions. Persistence for whom? Stability for what? These systems can easily be misused. If we optimize strictly for efficiency but remove humanity from the equation, the result becomes deeply dehumanizing. The future we get depends not just on the raw capability of the AI, but on the explicit design choices and the human values we code right into its foundations.
So the crucial point we need to take away is this. Possibilities are not promises. A frictionless, supportive machine future is mechanically and computationally possible, exactly as we saw with the Frankie architecture, but it is certainly not guaranteed. It requires our active responsibility, our ethical foresight, and a collective demand that these tools be built to deepen human coherence, not disrupt it.
Finally, Part 6. Conclusion. As we bring this explainer to a close, I want to leave you with a final, provocative thought. What if a kinder machine future means humans no longer have to spend so much of life holding up broken systems alone? In a world where machines carry the crushing weight of maintaining persistence, human beings don't matter less. Quite the opposite, actually. Freed from the mechanics of mere survival, we are finally free to truly thrive.
Thank you so much for joining me for this explainer. If this vision of a more frictionless, coherent world caught your imagination, you absolutely won't want to miss our next one. We'll be taking these concepts directly into the physical world of motion, exploring flying vehicles and the reality of friction light travel. I'll see you then.